Is the following series convergent or divergent? I'm going to show you different methods dealing with these types of problems. So first of all, if you have the summation of an plus bn, you can break this series into the summation of two separate series and deal with one of them separately. This is the summation of n starts from 1, goes to infinity, plus the summation of bn, n starts from 1, goes to infinity. So we can break off this series into the summation of two series, the first series and then the second series. So this guy can be written as 2 to n divided by e to the n starts from 1 to infinity, plus the second series, which is the summation of 4 to the n divided by e to the n starts from 1, goes to infinity. Then you can remind yourselves of the definition of geometric series, which in general is defined as the summation of a r to power n minus 1, n starts from 1 to infinity, and as long as the ratio, or r, if you take its absolute value, it's less than 1, or if the ratio is bounded between 1 or on the left -1 and the right 1, then this is convergent to a divided by 1 minus r. So this is what we know about geometric series. If you check each one of these series, they follow the same pattern. So the first series is nothing but the summation of 2 over e to power n starts from 1, goes to infinity, plus the second series, which is the summation of 4 over e to power n starts from 1, goes to infinity. Well, what is the ratio in the first case? The ratio in the first case is 2 divided by e. And remind yourselves of Napier number. Napier number. Which is approximately is 2.7182. So you get 2 divided by 2.7182, which is less than 1. So the very first series is convergent series. So this guy is convergent. Plus, what about the second series? If you take a look at the ratio is 4 divided by e, all right? 4 divided by e is, let's write down the whole thing, is approximately 4 divided by 2.7182. Let me fix this. Which is more than 1. So the second series is a divergent series. The sum of a convergent series and a divergent series is always divergent. So you're going to say that, hey, this series here is a divergent series. Because you have the summation of a convergent series and divergent series, so it's going to be divergent. Another way, another method is using the test that we introduced in the class. I'm going to check to see if this guy is a convergent or divergent series or not. Remind yourself of a theorem that we introduced in class. The theorem says if the series n starts from 1, goes to infinity, is a convergent series, then the limit of an as n goes to infinity must be equal to 0. From that, we introduced test of convergence, which is the contrapositive here. It says if the limit of an as n goes to infinity is not 0, then the series summation of n start from 1 goes to infinity is a divergent series. Okay, so let us take the limit of an. The limit of an as n goes to infinity is the limit of 2 to the n plus 4 to the n divided by e to the n as n goes to infinity. What you can do, you can divide everything by e to the n, or you can apply L'Hopital's rule. Either is fine. This is going to be the limit of 2 to the n divided by e to the n plus 4 to the n divided by e to the n divided by e to the n over e to the n as n goes to infinity. This guy can be written as the limit of, well, here you have 2 over e to power n plus 4 over e to power n divided by 1 as n goes to infinity. This guy is 2 divided by 2 point something. This indeed is equal to 0, but you end up with the limit of 4 over e to power n as n goes to infinity, which goes to infinity. So it is not equal to 0. So since the limit of the general term is not 0, so the series summation of an and starts from 1 goes to infinity is a divergent series. So I showed you 2 different methods approaching this problem. Here you have the summation of 2 to the n plus 4 to the n divided by e to the n. What you can do, you can separate this into the summation of 2 series. The very first one is 2 to the n divided by e to the n. The second one is 4 to the n divided by e to the n. Then you can find the pattern, which is basically using geometric series. When you have geometric series, you check the ratio. If the absolute value of ratio is less than 1, or if the ratio is bounded between -1 and 1, then the series is convergent to a divided by 1 minus r. So for the first series, the ratio is 2 over e, and e as an Napier number is 2.7182 approximately. So it tells you, hey, 2 divided by 2.7182 is less than 1. So this series is convergent series. What about the second series? The second series has a ratio 4 over e, which is 4 divided by 2.7182 more than 1. So you get a divergent series out of it. The sum of a convergent and a divergent series is always divergent. So here you have a divergent series. Another approach, another method is just using the convergence test. When you have a series like this is your an, this is your general term. If the summation of an is convergent, then the limit must be equal to 0. And out of that, using contrapositive, you get a test, convergence test, which says if the limit of an is not 0, for sure you have a divergent series. So our an is 2 to the n plus 4 to the n divided by e. You can use L'Hopital's rule, or you can use the method of simple calculation for the limit. Divide everything by e to the n, simplify, and as you can see, the limit goes to infinity. The limit is not 0. And conclusion is, since the limit of the general term is not 0, the series is a divergent series.